People on mountains age faster. It sounds strange, almost unbelievable, but according to modern physics, this is actually true. Two people living on the same planet, breathing the same air, can still experience time differently. One of them could technically grow older than the other, simply because of their altitude. Right now, somewhere on Earth, a person standing on a high mountain is aging a tiny bit faster than someone standing at sea level. The difference is incredibly small, but the idea behind it reveals something extraordinary about our universe. Because time is not as fixed as we think. Hello everyone, Kurumjari. Welcome to EePao Curiosity. For most of human history, people believed time was constant. Time moved forward at the same speed. A second passed here was the same for everyone in the universe. But in the early 20th century, Albert Einstein completely reshaped the understanding of time. Through his groundbreaking work known as the theory of relativity, Einstein proposed something revolutionary. Time is not absolute. Instead, time is connected to space, gravity, and motion. And depending on where you are or how fast you are moving, time can actually move faster or slower. This effect is known as time dilation. One type of time dilation happens because of gravity. The stronger the gravity around you, the slower time moves. The weaker the gravity, the faster time moves. Here on Earth, gravity is slightly stronger, closer to the surface of the planet. At sea level, Earth's gravitational pull is a little stronger than it is on top of a mountain. So if two people were compared, one living at sea level and the other living in the mountains, the person on the mountain would experience slightly weaker gravity. Because of that, time moves just a tiny bit faster for them. That means the person on the mountain technically ages faster. The difference is extremely tiny, only milliseconds over an entire lifetime, which is why we never notice it in daily life. But scientists have actually measured this effect using extremely precise atomic clocks. When identical atomic clocks were placed at different altitudes, the clocks at higher elevations ran slightly faster. This confirmed Einstein's prediction. This idea might sound abstract, but if you have watched the Christopher Nolan's movie Interstellar, you might remember a famous scene. Astronaut Cooper and Brand travel to a planet called Miller's Planet, which orbits extremely close to a massive black hole. Because the gravity near that black hole is incredibly strong, time on the planet moves much slower compared to the spacecraft that remain much farther away from the black hole. While Cooper and Brand spend only about 3 hours and 17 minutes on the planet, their teammate Dr. Romilly, who stays on the spacecraft Endurance, experiences 23 years, 4 months and 8 days passing. The difference shown in the movie is dramatic, but the science behind it is real. The enormous gravity of the black hole Gargantua slows down time tremendously. On Earth, this effect is far smaller, but the same principle still applies. But this raises an important question. Why does gravity slow down time in the first place? According to general relativity, gravity is not simply a force pulling objects together. Massive objects like planets and stars bend the fabric of space and time itself. Einstein described this combined structure as spacetime. Imagine spacetime like a stretched rubber sheet. When a massive object like Earth sits on it, it creates a deep curve, almost like a dent. Everything nearby, including matter, light, and even time has to move through this curved region. The deeper you are inside that gravitational curve, the slower time flows. Near the surface of Earth, gravity is stronger, so you are deeper inside that curve of space-time. On top of a mountain, gravity is slightly weaker, so you are a little higher on that curved surface. Because of this difference, time moves just a tiny bit faster at higher altitudes. So the next time you stand on a mountain, remember something fascinating. You are not just standing higher above the Earth, you are also moving through time slightly faster than someone at sea level. Time is not a perfectly steady flow. Time bends, stretches, and changes depending on gravity and motion. If this made you see the universe a little differently, stay curious. Thank you for watching EePao Curiosity.